Hi, welcome back, Geometry. So we are now ready to begin work on Standard 3, which as you see are properties related to triangles. Okay, so a level 1 is a beginning. It says for two of the ideas below, you can solve for variables, sides, and or angles in triangles using basic algebra. Okay, so you can use the triangle sum theorem, exterior angles theorem, or properties of isosceles triangles, or the equilateral equiangular triangles. Any two of those. Okay, for 2 to be approaching proficiency, you must be able to accurately use 3 to solve for variables, sides, and or angles in triangles using basic algebra. And to be proficient, you must be able to use all 4 to solve for variables, sides, and or angles in triangles using basic algebra. Okay, and then to get to that level 4, the exemplary, in addition to using all 4 to being proficient, okay, you can also apply more than one property in order to solve for missing angles involving more than one triangle. Okay, that's your exemplary. All right, so let's get started. Okay, so triangles and their interior and exterior angles. And if we look at that, we are going to start with a triangle. Okay, so for our introduction, we have a triangle. Okay, I just cut off a corner of a sheet of paper. Okay, it says to place the 3 corners together so that they all share the same vertex. So I'm going to take this, I'm going to leave this one. I'm going to take this corner off my triangle and have it share the same vertex. Okay, and then I'm going to take this corner off, if I can get it here. And I am going to have it share the same vertex as the other 2. Okay, what do you notice when we do that? Okay, hopefully you've noticed that this forms a line. Okay, with that being said, what do we know that the degrees are of these 3 angles if they form a line? Okay, we know they form 180 degrees. A line angles form 180 degrees. Okay, so what would you say is true then about the interior angles of a triangle? So would we know all triangles add up to equal 180 degrees? Okay, so let's do A, B, and C, finding the missing angles. Okay, so if we had 48 degrees here and 42 degrees here, what would angle A be? Well, we know 48 plus 42 is 90 degrees. So the measure of angle A would be 180 degrees because every triangle totals 180 degrees minus those 90 degrees that the 90 degree of the 2 other angles total. So measure of angle A equal to 90 degrees. So let's say measure of angle BAC equals 90 degrees. Okay, you could have said measure of angle A as it has there as well. Okay. Example B asks us to find the measure of angle DFE. Okay, so it's asking us to find the measure of this angle here, DFE. Okay, so that means again, a couple of different ways you could do this. So I added the 2 angles together and subtracted that from 180. Okay, could you have started with 180 degrees and subtract that 126 and that 31? You could have also done that. Okay, and we find that the measure of that angle is 23 degrees once we do that calculation. That's for the measure of angle DFE. Okay, and that adds up, calculates to be 23 degrees. Okay, and then the last one for now is asking you to find the measure of angle GIH. So again, find which way you like, and I'd try to be consistent with it and continue to do it that way. So 180 degrees, I can subtract what I know my other 2 angles equal. Okay, I prefer to add as much as I can. So I'm going to add 78 and 55 degrees and get 133 degrees. Okay, it's just easier for me to subtract one number, which is 133 degrees, than to subtract 78 and then subtract 55. Okay, so we get 47 degrees. So my answer up here, I can fill in 47 degrees. Okay, now, along with this, I didn't do it yet, but we're going to go back and do it. Okay, so 3 different kinds of angles. Triangles that we can say these are. Okay, we have right triangles, acute triangles, and obtuse triangles. Okay, so can you tell me what this triangle would be? Okay, it is a right triangle because we have a right angle in it. Right, a right angle, remember, is 90 degrees. Okay, the next one has one obtuse angle in it. So the triangle is an obtuse triangle. Okay, and here we have 3 angles that are less than 90 degrees, so it is acute. Okay, so think of acute like, oh, a cute little angle, right? A cute little angle is less than 90 degrees. Here's a 90-degree angle. Acute is less than 90 degrees. Okay, so let's get some theorems and definitions filled in here. So the blank interior, there are 3 interior angles of a triangle add up to 180 degrees. That is the triangle sum theorem. Okay, so let's look at classifying triangles by angles. It is acute when it is a triangle with 3 acute angles, right? All 3 angles have to be acute, less than 90. Equiangular is one we haven't talked about yet. And it is a triangle. Equa is almost saying equal. Okay, so it is a triangle with 3 equal angles. And if they have to be 3 equal angles, how many degrees would that be? If the total still has to be 180 degrees, and all 3 have to be equal, that puts us at 60 degrees, right? Okay, it is a right triangle when it is a triangle with how many right angles? With 1 right angle. We can't have 2 right angles, right? Because that'd already be 180 degrees, and you need 3 angles for a triangle. Obtuse is a triangle with how many obtuse angles? Good, just 1, because if you had more than 1, it wouldn't be a triangle. It'd be already greater than 180 degrees, because remember, obtuse means it's greater than 90 degrees. Okay, so obtuse, reminder, greater than 90 degrees. A right angle is equal to 90 degrees, and an acute angle is less than 90 degrees. So just some reminders. If you need to make note, make note. Okay, if that's something you know and remember, then that's fine. Okay, so definition of exterior. So exterior meaning angles outside the triangle. Okay, an angle that forms a linear pair, right? That's what happened when we put the angles together. We formed a linear. It was 3 of them, not a pair, but with an interior angle. Okay, an angle that forms a linear pair with an interior angle. Okay, so here, for example, we have an exterior angle, and it forms a linear pair with an interior angle. See that? An exterior angle here forms a linear pair with an interior angle here in the gray. Okay, so the exterior angle theorem then says that the exterior angle is equal to the sum of the two non-adjacent interior angles. Okay, so here's what that means. Okay, the exterior angle, this angle here, for example, is equal to the interior non-adjacent angles. So if we were to add these two angles together, add these together, and it would equal this exterior angle. Okay, and that's because the linear pair equals 180, as does the interior of a triangle. Okay, so here's an example. Okay, we can say, for example, here, the measure of angle MNP is equal to what? What would be the two interior non-adjacent angles? We would add this one here to this one here, right? So the measure of angle NPO plus the measure of angle PON. Okay. All right, so let's go do some examples. Work on applying what we just talked about. Okay, and again, feel free to go back if you need to rewind and listen through it again, or go back and get it written down, or pause it so that you can get it written down. Okay. Complete each problem, show all work possible, including classifying each triangle by angles. So, find the measure of angle A. Okay, so we're going to start with, or at least I start with, it doesn't mean you can't subtract, but I'm going to start with adding 99 degrees to the 41 degrees, and I get 140 degrees. So what does that mean I have to do to find angle A? Subtract what the two I already know from 180, and I get 40 degrees. Okay, sometimes I like to write it in there. And what kind of triangle would we say this is based on the angles that we have? Okay, it doesn't stand out as much as the other one, but it is obtuse because I have one angle that's greater than 90 degrees. Okay, here we're asked to find the measure of angle C in example 2. Okay, it doesn't have it written in there, but the little box, remember, in the corner says that's 90 degrees. Okay, so I can start by adding 90 degrees to 48 degrees, and I get 138 degrees. Okay, so then I'm going to take 180 and subtract that 138 and get 42 degrees for the measure of angle C. Okay, so if I've got 42 degrees, 48 degrees, and 90 degrees, how would I classify this? It's a right triangle because it has one 90-degree angle. Okay. And the last one, we're asked to find angle C. So again, let's add 60 to 65. That's 125 degrees. So to get angle C, I know I need to take 180 minus 125. And I get 55 degrees. So my answer for angle C is 55 degrees. If you want to see it in there, put it in there. Okay, based on the angles that I'm given in the triangle or have found, how would I classify this triangle? As acute, because they are all three acute. So the question I ask, is this equiangular? It is not, because the equiangular means all three angles are exactly the same, which would mean 60 degrees. Correct? Everybody with me? All right, let's go to page 2. And again, if you feel at this time like you can go ahead and do the remaining examples, feel free to go do them. Maybe do one or two and then play the video so you can check it. Okay, so example 4. All right, here we go. We got more than one triangle. Okay, we're asked to find angles 1 and 2. Okay, so to start with, I'm going to put 90 degrees here because I know this is 90 degrees. Right, that's what the box is saying. So if that's 90 degrees, what else do I actually know? Don't forget that we know a linear pair adds up to 180 degrees. So I know that that's also 90 degrees. Fill in things that you know that aren't necessarily written out for you, but are helpful in finding the angles that you need. Okay? So I'm going to add 90 to 76. I get 166 degrees. So the measure of angle 1 is 180 minus that 166, which is 14 degrees. So if I have 14 degrees, 76 degrees, and 90 degrees, what would we say this triangle is? It is a right triangle, right? And here I've got 90 and 27, which is 117 degrees. So to find the measure of angle 2, I'm going to take that 180 minus 117, and I get 63 degrees. And again, I would say it's a right triangle because I have one right angle. Excuse me. Okay, very good. So now we're going to look at when we have variables. Okay, you can solve for the unknown and then therefore find other angles, find what the actual angles are. Okay, so first we need to find x. Well, we know that the interior added together equals 180 degrees, right? 3x minus 3, or plus a negative 3, plus 2x plus 68. So let's simplify this left side to 5x plus 65 equals 180 degrees. And then do your 2 steps to solve. Okay, so we get x is 23 degrees. And then it asks for the measure of angle A, which is 3x, which is 23 degrees, minus 3. So 69 degrees minus 3 tells me that angle A is 66 degrees. Okay, so again, once you get the terminology down, it's back to those algebra skills, really. Okay, example 6. We want to find angles 1 and 3, and to start with, what can we fill in there that we really already know from previous knowledge? And that's that we have a linear pair here. Okay, so to find C, or angle 3, we can take 180 degrees minus 124 degrees and get 56 degrees. Okay, and if we know that's 56 degrees, now we're set using our new theorems and definitions, the triangle sum theorem, okay, to add 49 and 56, which is 105 degrees. Okay, so to find the measure of angle 1, I can now take 180 minus 105 degrees and get 75 degrees. And again, what kind of triangle would I have here if 1 is 75? That one would be an acute angle, right? Okay, here I'm asked to find the measure of angle 1 and 3 again, but they look different than the last one, so be careful. Okay, and where would you start here? I know 2 of my 3 inside, so interior angles, so I'm going to add 18 and 40 and get 58. So to get the measure of angle 3, I take 180, subtract 58, and I get 122 degrees. So in this case, even though angle 1 was listed first, it doesn't mean that's what I have to find first. Okay, what kind of triangle do I have if that's 122 degrees? Obtuse, good. I have one obtuse angle, so the triangle is an obtuse triangle. And so then what do I need to do to get angle 1? You can do one of 2 things. You can use linear pair and take 180 minus 122. Or you can add the alternate non-adjacent. You can add together the non-adjacent interior angles. Okay? So I can take 180 and subtract the 122 using linear pair. And I get 58 degrees. Okay? Or I can use what we just talked about on this first page, the exterior angle is equal to the sum of the 2 non-adjacent interior angles. The two non-adjacent would be 18 plus 40, which is 58. Okay, so we've got 58 degrees either way. So I just wanted to do both so that you're aware that you can use either one. Okay, two more, hang with me here. Find x. So we don't have to find any actual angles, we just have to find x. Okay, ooh, this one's a little harder, right? With x in there and not knowing an actual angle. Okay, so this one kind of forces us. We could use linear pair, but it makes it harder because of the x. So instead, let's use that the non-adjacent interior angles, so these two here, these two angles are equal to this one here. So I can say 5x plus 30 is equal to 4x minus 10 plus 3x minus 10. And again, you know me probably by now that I like to simplify before I go to solve. So 4x and 3x is 7x, a negative 10 and negative 10 is negative 20. Now let's move x's to one side, which means I'm going to add 20, the constant, to the other side. Always showing your work. So yes, everything I'm showing you should be showing as well. So x is 25 degrees. So could you find each of those angles? All three of them now, right? You could. Very good job. All right, last one. You can do it. Okay, this is going to be the toughest one we've got so far. So give it a shot. Okay, pause the video, see what you can get on your own without me talking you through it. Pause it, do it, and then hit play to check it. Okay, so to start with, we're going to use that the non-adjacent interiors are equal to the exteriors. So 9x minus 35 is equal to 3x plus 9 plus 58. Okay, I'm going to keep this one and simplify this side. Even though there's not a ton, I'm still going to simplify it. So I'm going to move my x's to the left to keep it positive, which means I'm going to add 35 over here. So 7x equals 102. And if I divide by 7, sorry, I was just checking to see if you were paying attention. 9 minus 3 is only 6. So I get 17. So x is 17. And if I know x is 17, can I find the angles that it's asking me to find? So the measure of angle O is 3 times 17 plus 9. So 51 plus 9 is 60 degrees. The measure of angle PNO, so PNO means the interior here. Okay, well, if I know this is 60 degrees, I can now take 58 plus 60 to get 118 degrees, and I can take 180 minus that 118 to get 62 degrees. Excellent job. Okay, and you should now be able to successfully go complete your homework 9 worksheet.